Hey everybody, David the AI Guide here on Saturday, and as you know, we're doing current events now mostly, and this is breaking news hot off the press from this week's research papers published, and this one comes out of a scientist named Wei Su at the Jet Propulsion Lab, which is operated by Caltech, the California Institute of Technology, and it's operated by Caltech for NASA. So it's a NASA research center, and these guys are doing amazing science over there. And this is a perfect example. So one of the things that's happened over the last 10 years as commercial space has come online, meaning SpaceX, the electronrocket, and other new space vehicles that are about to come online, like Virgin Galactic and Blue Origin. All of this has dramatically increased the rate at which satellites can be put up. So there's more and more and more satellites being put up all the time, and many of them are Earth observation satellites, and these satellites are designed to help people with planning of urban areas and helping for agricultural applications, looking at soil moisture and dryness and fires and all that stuff. But another one, the biggest one that impacts all of us all day, every day, is weather forecasting. So weather forecasting used to be not accurate, very accurate at all. In fact, if you go back more than 20 years ago, weather forecasts were generally accurate only up to 24 to 36 hours. So that was very short. What has changed this? Well, the thing that changed it dramatically is satellites. And you've got satellites that are in geosynchronous order, which means that they're looking at a part of the Earth, the same part of the Earth all the time. And then there's satellites in polar orbit, which look at the same parts of Earth several times each day because they're going pole to pole over the Earth like that. And this has profoundly transformed weather forecasting. So now instead of 24 to 36 hours, say 25 years ago, now weather forecasts are generally accurate out to 3 days, which is double or more than double their previous rate of accuracy. But another thing that's happened is all these satellites have been put up in the last 10 to 20 years, and mostly the last 10 because of the dramatic increase in the rate of rockets flying to space, is an avalanche of data. And this is so much data that it's impossible for human researchers to go through all this data. It's absolutely impossible. So today's topic out of JPL is that Wei Su and her team have been using machine learning to try to improve forecasting of hurricanes. And why is that important? Well, we all know why. A Category 4 hurricane just hit the Louisiana coast and did massive damage. So these hurricane events can be very life-threatening and cause tremendous property damage. So this kind of forecast improvement is critical to human safety and well-being. The interesting thing is that there's a subset of hurricanes that increase in intensity very, very quickly. And this most recent hurricane was a perfect example of that. These are hurricanes where the core wind speeds that determine what category the hurricane is, 1 through 5, these rapidly intensifying hurricanes have increases in wind speed of 35 miles per hour or greater within 24 hours. So these are hurricanes that do not appear to be very severe. like the one that just hit when it's out at sea, and then it suddenly intensifies right before landfall and causes catastrophic damage. So this is something that needs to be addressed in terms of research very urgently. And as you can imagine, hurricanes are very, very complex storms. They have so many different factors that are occurring in them at any given time that a human cannot evaluate all those factors. Enter AI, which is what we talk about every week, twice a week, to fix that problem. And we've talked about this in some of the other videos, that AI can see patterns that humans cannot, because one, the data set is way too big to be absorbed by a human being, or B, the correlations are too subtle to be noticed by a human being. And we've talked about the fact that humans can only notice very obvious correlations. Well, Wee Sue and her team used an IBM Watson platform to design algorithms that would be complementary to the existing models that the National Hurricane System uses, but focus particularly on these storms that rapidly intensify. And they came up with 3 factors that they didn't realize correlated to this rapid intensification. And this was literally just published this past week. So this is brand new information, all courtesy of AI. One of the things is the rate of rainfall in the hurricane within 60 miles, 62 miles to be precise, of the hurricane eye wall, which is the center of the storm. So that is one factor that is very important to determining whether a hurricane will rapidly intensify. They discovered a second factor, which is the ice water content. So clouds are made up of liquid water and water in ice form, because very tall thunderstorms, like at the center of hurricanes, have very, very cold temperatures. And the more ice water content, in addition to the higher the rainfall rate, the more likely these hurricanes are to suddenly intensify. And then the third factor they found that they didn't realize, none of these were known before this research was done. The third factor is called outflow temperature, and that's the temperature that's flowing out from the center or the eye of the hurricane, that flows out of the eye and along the top of the hurricane. So the lower those temperatures, the more likely that a hurricane is to rapidly intensify. So when you add these 3 factors to the previous model that the National Hurricane Center was using, suddenly the degree to predict which hurricanes would go through this rapid intensification was improved by 60%, where the winds met that 35 miles per hour or more intensification in 24 hours criteria. So 60% better forecasting, but in a smaller set where the winds increased by 40 miles per hour or more, which this last storm did, the accuracy of predicting these rapid intensification events went up by 200%. And this was looking at a 20-year database of actual hurricanes that occurred. So once again, machine learning, and this is a deep learning algorithm, most likely. They didn't say, but most likely it is, because that was the big breakthrough that we've talked about in machine learning that is transforming AI. But this most likely deep learning algorithm that Wee Sue and her team used has transformed the prediction of hurricanes that might rapidly intensify, and that allows the government and the Weather Service to notify people much earlier to get out and watch out for these extremely damaging storms that rapidly intensify at the last minute. So huge breakthrough just this week from AI and machine learning that benefits humanity. Talk to you on Tuesday. And if you like this video, please like it. And as always, please subscribe if you would like to see more. And thank you so much for watching my channel.